While it may not have been the apex predator of its time, dwarfed by monstrous crocodilians and giant snakes, it was a harbinger of things to come. Little did the other inhabitants of ancient South America know that they were witnessing the birth of a dynasty that would reign for millions of years. As the Eocene progressed, so did the terror birds. Nature, it seemed, had plans for this lineage of avian predators, and those plans involved getting bigger, much bigger. Just 3 million years after Paleopsilopterus took its first steps, a new player entered the scene. Eluthaornis, a terror bird that stood 50% taller than its ancestor, emerged as a formidable predator. But Eluthaornis wasn't content with merely growing in size. It also expanded its range in a way that no other terror bird would match. While most of its kin would remain firmly rooted in the Americas, Eluthaornis spread its wings and ventured across the sea to Europe. Fossil remains of this globe-trotting terror have been found in both France and Switzerland, making it the only known member of its family to have lived outside the New World. One can only imagine the surprise of early European mammals when this exotic predator appeared in their midst, bringing a taste of South American terror to the Old World. But Eluthaornis was just the opening act. As the epochs rolled by, the terror birds continued to grow, adapt, and diversify. But as impressive as Titanis was, it was dwarfed by its cousins back in South America. Kelenken, named after a mythological Tehuelche spirit, stood a towering 3 meters, or 9.8 feet tall, and weighed around 250 kilograms, or 550 pounds. This was a bird the size of a grizzly bear, with a head larger than that of a horse, and a beak that could crush bone. Speaking of its, I've always been struck by the unique skull structure of the larger terror birds, like Kelenken. Recent studies have shown that this adaptation wasn't just a quirk of evolution. It gave them a bite force and pecking power that set them apart. It makes me wonder if they could truly take down the megafauna that roamed South America during their time. The debate over which terror bird was truly the largest is fascinating. Brontornis, though slightly shorter than Kelenken at 2.8 meters, was a feathered bulldozer, potentially weighing up to 400 kilograms. That would make it the heaviest carnivorous bird of all time. There's even some controversy around Brontornis, with some paleontologists questioning whether it was truly a terror bird or even a carnivore. They cite similarities in its toe claws to those of herbivorous birds. But recent studies have identified features in Brontornis's vertebrae that are unique to terror birds, which lends weight to its classification as a member of this fearsome family. Regardless, its massive size would have made it a force to be reckoned with. It might have been slower than its more nimble cousins, but what it lacked in speed, it made up for in raw power. I can almost picture Brontornis as the tank of the terror bird world, capable of steamrolling over any prey that was unfortunate enough to cross its path. While some giant terror birds relied on their size and power, many others took a different approach: speed. Studies of terror bird leg bones have revealed a structure remarkably similar to that of modern-day ostriches: short thigh bones paired with elongated lower leg and foot bones. This is a clear indicator of high-speed running ability. Paleontologists estimate that many terror birds, including some of the larger species like Titanis, could have reached speeds exceeding 30 mph. That's faster than Usain Bolt, while standing twice as tall and weighing several times as much. But speed wasn't just about chasing down prey. For many terror birds, especially the smaller and medium-sized species, it was also a crucial defensive adaptation. In a world filled with other large predators, including giant carnivorous mammals and enormous crocodilians, the ability to make a quick getaway could mean the difference between life and death. This combination of speed and size made terror birds versatile predators capable of adapting to a variety of hunting strategies. Smaller, faster species might have specialized in chasing down swift prey, like small mammals and reptiles, while the larger, more powerful species could have employed ambush tactics, or even taken on larger, more dangerous quarry. While their imposing size and fearsome beaks often steal the spotlight, the true power of terror birds lay in their highly developed senses. Recent studies of terror bird skulls and brain cases have revealed that these prehistoric predators were equipped with sensory capabilities that put them leagues ahead of many of their contemporaries. While terror birds might not have had eyesight quite as sharp as modern raptors like eagles or hawks, they were far from being visually impaired. Their eyes were well developed and positioned to provide excellent depth perception, a crucial advantage for any predator. But what really set terror bird vision apart was its versatility. These birds were equally adept at seeing in bright daylight and in the dim light of dawn and dusk, making them effective hunters around the clock. The inner ear structure of terror birds suggests an acute sensitivity to low-frequency sounds. This ability would have allowed them to detect the footsteps and movements of potential prey, even when hidden by dense vegetation. I imagine a terror bird standing motionless in the prehistoric forests of South America, its head cocked slightly to one side. However, as is often the case in science, the truth has turned out to be more complex and nuanced. Recent studies have cast doubt on this simple competition-based extinction model, revealing a more intricate tapestry of factors. The terror birds. Their name alone evokes a sense of primeval dread. But what I find most fascinating is that their reign wasn't ended by some cataclysmic event, but perhaps by something as subtle as a shift in the weather. Or was it? For years, I thought they'd vanished 1,000,000 years ago. But recent fossil discoveries have pushed that date much closer to our own time. Could humans have nearly crossed paths with these feathered giants? The competition hypothesis, the idea that placental predators drove them to extinction, has always seemed a bit too simple. The fossil record shows that many terror birds and their South American competitors had already disappeared long before those placental predators arrived in significant numbers. It's a timing mismatch that suggests other factors were at play. And then there's Titanis, who successfully expanded its range into North America during the Interchange, coexisting with large canids and felines for millions of years. It proves that at least some terror birds were more than capable of holding their own against mammalian predators. So, if it wasn't just competition, what else contributed to their downfall? Climate change, I suspect, played a significant role. Other megafauna that coexisted with early humans, like woolly mammoths and giant ground sloths, left lasting impressions on human culture and mythology. The near miss between humans and terror birds is a reminder of the incredible diversity of life that has existed on our planet. It's sobering to think that if the terror birds had managed to hang on for just a few thousand years longer, our understanding of the natural world might be very different today. Speaking of dominant animals, it brings to mind the big cats. The lion may be the king of the jungle, but the tiger stands out as the largest, most powerful, and most skilled of them all. Yet, there was one species in particular that dwarfed even the modern tiger in size, ranking among the largest cats to ever exist, the Nandong tiger. In the early 20th century, Dutch paleontologists excavating near the village of Ninggandong on the island of Java in Indonesia made a remarkable discovery. They unearthed bones belonging to a tiger, but these weren't the regular Bengal tiger bones they were used to. These were bigger than any tiger anyone in the modern world had ever seen. Further research and analysis of additional fossils revealed more astonishing details about this huge tiger. For thousands of years during the Pleistocene epoch, the Gandong tiger roamed the Sundaland region of Southeast Asia, striving to establish itself as the dominant apex predator. This formidable beast was larger than its modern-day counterparts, with adults weighing up to 20 to 25% more than the average present-day Siberian tiger. Larger males typically weighed upwards of 400 Kelenken, making them contenders for the title of largest felines ever. Judging from the enormous size of these giants, it's easy to assume that tigers have always been this large. However, history tells a different story. Early tigers, existing long before the Nandong tigers, were notably smaller in terms of body size and weight. This smaller stature could be attributed to the available prey and the ecological niches they occupied. A smaller body size offered energy conservation and agility advantages across various terrains. Early big cats related to tigers, such as Panthera paleocinensis, likely averaged around 70 to 120 kilograms in weight. Following them was the Trinil tiger, popularly believed to be the ancestor of all known Indonesian subspecies. I find myself constantly drawn back to the image of the Nagandong tiger. Imagine being an apex predator ruling the wild at the top of the food chain. Life at the top has its perks, certainly. But here's the thing I keep turning over in my mind. Even the most fearsome hunters aren't always the biggest beasts around. Because when it comes to the predator game, size isn't everything. When it comes to size, it appears that they were relatively evenly matched, at least with the largest species of Smilodon. Smilodon populator weighed between 220 and 436 kilos and stood about 120 centimeters tall, which is not that far off from that of the Nandong tiger. A less formidable rival, perhaps, would have been the giant short-faced hyena, standing about 90 to 100 centimeters at the shoulder and averaging 110 kilograms in weight. However, the dire wolves presented a different kind of challenge. Though they had smaller jaws and weighed less than the Nandong tiger, they hunted in packs of more than 4 individuals. As a solitary hunter, it would have been incredibly difficult for the Nandong tiger to match that intensity when attacking prey. This factor placed it at a disadvantage in the competition for apex predator status. But the Nyandong tiger had more to worry about than just other predators. Around this time, early humans were becoming increasingly prevalent in Southeast Asia. Over 80 individual remains have been found in that region. So it's likely that they would have crossed paths with the Nyandong tiger. At first glance, such encounters would seem overwhelmingly unfavorable for the early humans, given their relatively small size compared to such a massive predator. But to say that would be to underestimate their intelligence. This feline was far more robust than any modern cat, a true heavyweight champion of the Ice Age. In light of this revelation, a new name was in order. Thus, Smilodon populator was born, knife-tooth, roughly translated to the destroyer. It's a fitting moniker for a predator that redefined what it meant to be lethal. The scientific community dove headfirst into unraveling the Smilodon's family tree, a quest that continues to this day. Researchers currently place our knife-toothed friend in the extinct subfamily Machairodontinae, home to most of what we colloquially call saber-toothed tigers. Though saber-toothed cats is more accurate, since these ancient felines aren't closely related to modern tigers, or any living cats for that matter. In fact, their closest living relatives might be members of the Felinae subfamily, which includes our domestic kitties. Within the Machairodontinae, Smilodon found itself in an even more exclusive club, the Smilodontini, or, as some paleontologists like to call them, the dirk-toothed cats. This group is pretty exclusive, with only 5 known genera calling it home. But what Smilodontini lacks in diversity, it makes up for in star power, thanks to Smilodon. Smilodon wasn't a lone standout. It was more like a prehistoric trio with 3 distinct members: Smilodon gracilis, Smilodon fatalis, and Smilodon populator. Almost twice as wide as a human can manage. Smilodon wasn't just brawn and teeth. Brain scans suggest that these prehistoric predators had excellent coordination, sharp hearing, and top-notch vision. Their eye socket shape hints at binocular vision, giving them the depth perception needed to judge distances accurately, crucial for a predator that relied on ambush tactics. And they were fast, too. Many Smilodon fossils show trauma to their sternums, the kind of injury you'd expect from high-speed collisions. Smilodon's unique traits, along with its powerful weaponry, made it a versatile hunter capable of taking down a wide variety of megafaunal prey. In North America, their prey included oversized versions of animals we recognize today: giant bison, camels, and even mastodons and Columbian mammoths. In South America, Smilodon's targets included creatures like Toxodon, Litopterna, various species of Glyptodon, along with more familiar animals such as horses and camelids. Some evidence even suggests that Smilodon occasionally went after caimans. We know what Smilodon ate thanks to skeletal evidence such as tooth marks on bones, or Smilodon remains found alongside those of their prey. One big question that's still hotly debated in paleontology circles is whether Smilodon was a lone hunter or a team player. Knowing whether Smilodon hunted in packs could tell us a lot about its social structure and what kind of prey it typically targeted. One of the strongest pieces of evidence supporting the idea that Smilodons lived socially comes from the La Brea tar pits in California. These tar pits are a gold mine for paleontologists, preserving countless Ice Age animals that got stuck in the sticky asphalt. But most of the bones found in La Brea aren't from herbivores that got trapped, but from predators that got stuck trying to eat the trapped herbivores. Smilodon fossils are the second most common find in these pits, with over 166,000 bones attributed to it. This high number has led some scientists to suggest that Smilodon might have been a social animal. The reasoning goes like this. In modern cat species, the more social ones tend to be more responsive to distress calls. So, if one Smilodon got stuck, it might have called for help, attracting other members of its group who then also got stuck. Another fascinating clue pointing to Smilodon's possible social behavior is surprisingly touching. Some Smilodon fossils show signs of severe injuries or disabilities that would have made hunting nearly impossible. Yet, these individuals survived well into adulthood. This has led some paleontologists to propose what they call pseudo-healthcare among Smilodons. The idea is that these injured I've often wondered about the social lives of extinct creatures. Imagine a world where saber-toothed cats, Smilions, cared for their injured, much like lions or wolves do today. But lions and wolves weren't the only competition. The Ice Age also had the short-faced bear, a beast that could make even Smilodon look small. Some reached dinosaurian proportions. However, these bears were more omnivorous, which reduced direct competition. Plus, bears tend to be solitary. So, if a group of Smilons encountered one, the bear might have decided it wasn't worth the trouble. We've talked about Smilodon's hunting adaptations, but how did it eat with those teeth? Those saber-like fangs seem like they'd be an obstacle. Well, Smilodon had a solution. Unlike most predators, it couldn't chomp down from the front. Instead, it had specialized slicing teeth called carnassials on the sides of its mouth, working like biological scissors. To eat, Smilon would have turned its head, using these carnassials to slice off chunks of meat while its saber teeth stayed out of the way. It's a technique you might have seen in modern cats when they tackle tough pieces of meat. It's a prime example of nature's problem solving. When life gives you saber teeth, you adapt your eating style. With its unique adaptations and hunting prowess, Smilodon carved out a vast empire. Its 3 species achieved a distribution across the Western Hemisphere that would make any modern predator envious. In North America, Ezralis and Esfatalis roamed from coast to coast, reaching as far north as Alberta, Canada. Meanwhile, in South America, Esfatalis and Espopulator established a domain stretching all the way down to Patagonia. Smilodon wasn't just geographically widespread, it was also adaptable. Fossils have been found in diverse environments, from grasslands and plains to woodlands and closed forests, from savannas to subtropical forests, and even mammoth steppes. This allowed Smilodon to live alongside a veritable who's who of Pleistocene megafauna. We're talking about a world where you might encounter short-faced bears, proboscideans, ground sloths the size of cars, armored glyptodons, the rhino-like toxodon, camels, deer, horses, bison, and even terror birds. It was like a real-life version of the ice levels in every video game, but with 100% more lethal prehistoric cats. But there was one more species that Smilodon encountered in its twilight years, one that would change the face of the planet forever: humans. It's believed that our ancestors might have first crossed paths with Smilodon around 25,000 years ago. Imagine being one of those early humans, armed with nothing but primitive tools, coming face to face with a saber-toothed cat. The relationship between humans and Smilodon was likely tense. After all, we were competing for many of the same food sources. And, unfortunately for our ancestors, by the time humans arrived, only the largest populator and Espatulus remained. Talk about bad timing. This was the nightmare that redefined what it meant to be an apex predator. A monster that could rival and, in many ways, surpass even T-Rex itself. The first thing that truly unsettles you about Spinosaurus isn't its length, though at 50 to 59 feet, it dwarfs even the largest T-Rex specimens. It's not even the massive sail rising from its back like some prehistoric fin. No, it's how perfectly wrong everything about this creature appears, and yet how devastatingly effective each bizarre feature proved to be. Consider that skull. A narrow, elongated nightmare stretching nearly 6 feet long. If you've ever stared into the eyes of a large crocodile, you understand the primal fear that comes from seeing a predator perfectly designed for aquatic ambush. Now, imagine that same sinister profile scaled up to dwarf any modern crocodilian, mounted on a body that could rear up 20 feet into the air. The skull alone weighed as much as a small car, yet it cut through water with the efficiency of a torpedo. Those jaws housed over 60 interlocking teeth, each one a curved, needle-sharp instrument of death designed for one purpose: gripping slippery, struggling prey underwater. Unlike the bone-crushing teeth of T-Rex, built for delivering massive bite forces to terrestrial victims, Spinosaurus's teeth were fishing spears made of enamel. Once those jaws clamped down on a 15-foot sawfish or massive lungfish, escape became physically impossible. But the skull was just the beginning of this creature's aquatic arsenal. Where other theropods developed powerful legs for running down prey across land, Spinosaurus rewired its body for a different kill zone. Its toes were webbed, its legs positioned differently, its entire lower body redesigned for propulsion through water rather than speed across terrain. For anything living in those rivers, the nightmare was the same: the faint ripple at the surface, the sudden silence, and then the 7-ton shadow sliding in after you. And while most large theropods had relatively small forelimbs, Spinosaurus possessed powerful, elongated arms, ending in massive claws. These weren't vestigial appendages. They were additional weapons, perfectly positioned for grabbing prey, maintaining balance in water, or delivering killing blows. The creature could literally embrace its victims to death. And then there's the sail, rising up to 7 feet above its spine. This massive dorsal fin dominated Spinosaurus's silhouette like the warning flag of death itself. Scientists debate its exact function: thermoregulation, display, fat storage for surviving dry seasons. But its psychological impact is undeniable. Picture this nightmare rising from murky water. First, the elongated snout breaking the surface, then those cold reptilian eyes, and finally, that towering sail cutting through the air, like the dorsal fin of some impossible shark. Imagine being a fish in the rivers of Cretaceous Africa. Even more disturbing was how Spinosaurus turned the very act of drinking water into a death trap. Every animal needed to approach rivers and lakes to survive. For millions of years, this had been a calculated risk. Stay alert, drink quickly, watch for crocodiles. Suddenly, the riverbank became unreliable. That submerged log might be a 50-foot predator. Those ripples might indicate something that could strike from below with the force of a freight train. The fossil evidence suggests Spinosaurus didn't just occasionally venture into water. It lived there. This wasn't a terrestrial predator wading in for a quick meal, but a creature so perfectly adapted to aquatic life that it spent most of its time submerged, transforming ancient waterways into hunting territories more dangerous than any terrestrial predator could create. In a world where survival depended on understanding and avoiding threats, Spinosaurus represented something unprecedented. A predator that eliminated the fundamental distinction between land and water safety. It didn't just dominate two worlds, it merged them into a single inescapable killing field. And we can't be talking about the perfect killing machine without mentioning its teeth. Conical, dagger-like, and built to clamp down on prey that thought the water would save them. Each one angled backward like barbed hooks, creating a living fish trap built on a terrifying principle: easy entry, impossible exit. It shared its territory with a deadly mix of predators, prey, and rivals. On land, giants like Carcharodontosaurus patrolled, while Sarasuchus, a 40-foot super croc, competed for aquatic hunting grounds. Mid-sized hunters like Rugops cleaned up leftovers, and swift predators like Deltadroius used speed to carve out their place. Herbivores like Ouranosaurus and the colossal Paralitoton somehow survived this gauntlet, and the waters were filled with monstrous prey like entroprist and lungfish. Every species in this ecosystem lived in constant tension with Spinosaurus's dominance. Land predators maintained uneasy truces, herbivores relied on elaborate survival tactics, and aquatic prey developed increasingly tough defenses. The last Spinosaurus died approximately 94 million years ago. But the questions this creature raises about predation and survival continue to ripple through our understanding. The skull. It was unlike anything I'd ever seen. Specialized, enlarged premolars, a cranial structure more like a lion or hyena than any dog I knew. It posed a challenging question. What was this creature? The answer, as so often, lay in the skull itself. Those specialized premolars, that robust jaw, they pointed directly to the Paraphysornis subfamily. This group, one of the most successful branches of the canid family, remains strangely obscure to most people. The Paraphysornis were incredibly diverse, with 66 known species. They had powerful teeth, short but deep jaws, and a fifth toe, which many modern dogs have lost. For over 15 million years, they dominated North America, evolving into a remarkable range of forms. Some were fox-sized, others rivaled modern grey wolves. And then there was Epicyon, the ultimate bone-crushing dog. Its name literally means more than a dog. Recent studies of modern canids have helped paleontologists understand where Epicyon fits. The Paraphysornis were a highly specialized branch, following a different evolutionary path then the lineage that led to modern wolves and dogs. This specialization explains Epicion's unique features and, perhaps, its eventual disappearance. Within the Epicion genus, 3 distinct species emerged, each filling a different ecological niche: E. savus, E. elodontoides, and E. haydeni. While all 3 were formidable predators, they differed in size and build. The smaller species, savus and elodontoides, were more gracile, built for agility and speed. Even these smaller Epicion species typically weighed twice as much as a modern German shepherd. But it was Epicion haydeni that truly pushed the boundaries. Adults reached lengths of 2.4 meters, nearly 8 feet, rivaling a grizzly bear. They stood 90 centimeters, about 35 inches, at the shoulder, like a wild deer. These giants weighed between 125 and 170 kilograms, 275 to 375 pounds, heavier than modern leopards, and comparable to large jaguars. Intriguingly, E. haydeni exhibited significant size polymorphism, meaning individuals of the same species varied greatly in size. Some specimens matched medium-sized male lions in weight, making them the heaviest canids ever known. But Epicion's most remarkable feature was its bite. Biomechanical studies reveal it possessed one of the most powerful biting mechanisms ever seen in a mammalian carnivore. Enlarged premolars and strategically positioned canine teeth, closer to the jaw joint than in modern canids, created a highly efficient biting apparatus. Analysis suggests Epicion's bite force may have exceeded 16,000 newtons, comparable to a large American alligator. The closer placement of the canines to the jaw joint created a more efficient lever system, concentrating enormous force at the tooth tips. The result was a bite that could easily pierce hide, flesh, and even bone. Microscopic analysis of wear patterns on preserved teeth provides direct evidence of how Epicion used its bite. The patterns are consistent with both flesh slicing and bone crushing, suggesting a predator that could efficiently process every part of its prey. Fossil deposits indicate Epicion was an opportunistic predator, taking down a wide range of prey, including ancient camels, pronghorns, horses, and peccaries. They even hunted prehistoric rhinoceros species like Teleoceras, which could reach lengths of 4 meters and weigh nearly 2 tons. Epicion may have employed different hunting strategies based on prey size and availability. For smaller prey, they likely hunted alone or in pairs, using their speed and power to overwhelm victims. However, evidence increasingly suggests they also engaged in pack hunting, particularly when targeting larger prey. Nearly all well-studied modern canids exhibit some degree of social behavior, with most species showing higher levels of sociality than the average mammal. Most extant canids hunt cooperatively, with only a few exceptions like foxes and some small canid species. The fossil record provides further support for this theory. The bones of Epicion, an ancient carnivore, are among the most common remains we find in North American deposits. What strikes me is that their abundance suggests something beyond solitary hunting. It points to stable populations across their range, something we typically associate with animals that hunt in packs. The very build of Epicion tells a story. They weren't sleek and agile like modern wolves. Instead, they possessed a robust, heavier skeletal structure. While this might have limited their speed and endurance, it would have been a real advantage in close-quarters combat, especially against large prey. Their limbs, it seems, were built for short, explosive bursts of power. I imagined them relying on ambush tactics or quick chases rather than the long-distance pursuit we see in wolves today. What I find particularly interesting are the recent discoveries of epicyon remains in cave systems and edge environments. These areas, where different habitat types intersect, suggest a strategic approach to habitat selection. They preferred areas that provided both hunting opportunities and shelter. Their teeth suggest they could process tough plant material when necessary. This dietary flexibility, combined with their bone-crushing abilities, would have allowed them to survive in a wide range of environments and through various seasonal changes. The disappearance of epicyon from the fossil record has long intrigued paleontologists. Early theories suggested competition from newly arriving big cats was to blame. But many of the large cats that would have competed with Epicyon, like the saber-toothed cat Smilodon, didn't appear in North America until millions of years after Epicyon's demise. Current evidence points to climate change as the primary driver of their extinction. The late Miocene saw significant global cooling and increased aridity. This led to fundamental changes in North American ecosystems. Paleobotanical studies indicate a shift from mixed woodland savanna environments to more open grasslands. This transformation would have affected not only the types of prey available, but also the hunting strategies. The very name Ankylosaurus hints at the story. Fused lizard, a nod to its remarkably fortified skeleton. In 1906, Barnum Brown, a paleontologist from the American Museum of Natural History, led an expedition into Montana's Hell Creek Formation. It was there, amidst layers of Cretaceous sediment, that he unearthed fossils that initially perplexed him. These weren't the familiar bones of theropods or the broad frills of ceratopsians. Instead, Brown uncovered fragments of bony plates, uniquely shaped teeth, and vertebrae that suggested a heavily armored animal. Early interpretations were cautious. Brown initially speculated that these bones might belong to a previously unknown type of armored dinosaur. Over time, further excavations in Canada and the western United States revealed more specimens, each shedding light on the creature's unique physical characteristics. The painstaking process of piecing together its skeletal framework was like assembling a prehistoric jigsaw puzzle, with each discovery adding a layer of complexity. What made Ankylosaurus magnaventris truly stand out was not just its robust anatomy, but also its ecological implications. Fossils of Ankylosaurus were found in association with remains of plants, hinting at the lush environments it inhabited. Over the decades, advances in paleontological techniques, including CT scanning and isotope analysis, have allowed scientists to reconstruct its appearance and understand its lifestyle in remarkable detail. From the armored plates that defined its body to the distinctive club at the end of its tail, Ankylosaurus epitomized nature's ingenuity. This discovery was groundbreaking because it didn't just represent a new species. It became the cornerstone of an entirely new group of dinosaurs, the Ankylosauria. These animals, belonging to the larger clade Ornithischia, were characterized by their extensive armor plating and herbivorous lifestyle. Within this group, Ankylosaurus belonged to a more specialized family, the Ankylosauridae, distinguished by their massive triangular skulls, stocky builds, and elaborate defensive features. But among all its relatives, Ankylosaurus held a special distinction. It was the largest of its kind ever discovered, with adults reaching lengths of 17 to 33 feet and standing about 5 feet at the hip. More impressively, these titans weighed between 5 and 8 tons, surpassing even the famously robust Triceratops in mass, and rivaling the earlier aquatic predator Spinosaurus. One might wonder how a relatively low-slung animal could pack such impressive weight into its frame. The answer lies in its extraordinary construction. Imagine a biological tank meticulously designed for strength and survival. The Ankylosaurus's skeleton was built unlike any other dinosaur, with dense, compressed bones forming a sturdy foundation for what would become one of nature's most sophisticated armor systems. All of this was supported by a framework of highly modified vertebrae, specifically adapted to handle the stresses of high-speed impacts. The mements are truly staggering. Specimens show the club could reach 57 centimeters or 22.5 inches in width and weighed approximately 23 kilos or 50 pounds. But these numbers only tell part of the story. The real marvel was in the biomechanics. Advanced computer modeling has shown that large individuals could generate impact forces exceeding 20,000 newtons. Even more remarkably, they could achieve swing impulses of up to 4,800 newtons per second. To put this in perspective, while a professional baseball player generates about 13 newtons per second in their swing, the Ankylosaurus's tail strike was 370 times more powerful. Recent studies using finite element analysis have even suggested that the impact force could have been focused on an area as small as a few square centimeters, multiplying its bone-crushing potential. It's an incredible feat of natural engineering. The behavior and lifestyle of Ankylosaurus were as unique as its anatomy. While much of its life remains a mystery, fossil evidence offers glimpses into its daily routines and survival strategies. Juvenile Ankylosaurus specimens, for example, lacked the fully developed armor and tail clubs seen in adults. This vulnerability likely necessitated group behavior during the early stages of life. Trackway fossils suggest juveniles may have formed protective herds, with larger individuals shielding the more vulnerable young in the center, a defensive strategy reminiscent of modern musk oxen. As they matured, Ankylosaurus individuals underwent significant lifestyle changes. Adults appear to have been predominantly solitary, a conclusion supported by the rarity of adult specimens found in groups. Their solitary behavior was likely a reflection of their formidable defenses, which allowed them to traverse their environments without fear of predation. Solitary adults might have roamed large territories, primarily in search of food and suitable habitat, avoiding direct competition with other herbivores. Some paleontologists have speculated that Ankylosaurus might have used its tail club for intraspecific communication or dominance disputes. This theory is supported by observations of similar behaviors in modern animals with physical weaponry, such as bighorn sheep or rhinoceroses. The display of their tail clubs, combined with body size and posturing, could have deterred rivals without escalating into physical conflict. However, the evidence remains inconclusive, and further fossil discoveries may provide clarity on this aspect of their behavior. Ankylosaurus thrived in the rich and dynamic ecosystems of late Cretaceous North America, particularly in regions that would later become known as the Hell Creek Formation. This area was a mosaic of environments, ranging from subtropical forests to open floodplains teeming with diverse flora and fauna. Fossilized plant remains suggest Ankylosaurus inhabited regions with abundant low-growing vegetation, which suited its low-slung, ground-grazing body. The climate of the late Cretaceous was warmer and more humid than today, which supported lush forests dominated by conifers, cycads, and ferns. Ankylosaurus likely played a role in shaping this ecosystem, though not as extensively as herding dinosaurs like hadrosaurs. Instead, its selective feeding habits might have influenced plant growth patterns in localized areas. The association of Ankylosaurus fossils with specific types of vegetation has led researchers to hypothesize that they may have helped disperse seeds, inadvertently promoting plant diversity. Seasonal changes would have impacted the behavior of Ankylosaurus. Fossil evidence indicates that some regions experience dry and wet seasons, influencing the availability of food resources. Ankylosaurus may have adapted by modifying its diet or undertaking small-scale migrations to follow vegetation growth. The robust construction of its body, coupled with its ability to consume tough plant material, would have allowed it to survive in less than ideal conditions. The coexistence of Ankylosaurus with large herbivores like Triceratops and Edmontosaurus, as well as apex predators like Tyrannosaurus rex, paints a vivid picture of its ecological niche. While Ankylosaurus was not the most numerous dinosaur in its ecosystem, its defensive adaptations end its survival alongside fierce competition. Its presence in these environments exemplifies a remarkable story of adaptation and resilience. The Ankylosaurus. Even its diet was a finely balanced food web, where specialized roles allowed diverse species to coexist. I find myself often pondering the ways in which the most formidable creatures are also the most intricately designed. The diet of Ankylosaurus was primarily herbivorous, and its adaptations were impressive in their effectiveness at processing tough, fibrous vegetation. Its broad, low-slung muzzle and simple ridged teeth were ideal for stripping and grinding low-growing plants, such as ferns, cycads, and horsetails. Unlike some herbivorous dinosaurs that had elaborate dental batteries, Ankylosaurus relied on its powerful jaw muscles to break down plant material before swallowing. Recent studies of Ankylosaurus teeth have revealed wear patterns that suggest a surprising degree of dietary flexibility. While its primary diet consisted of vegetation, it may have occasionally consumed protein-rich fungi or small invertebrates, inadvertently gathered while feeding. It's a fascinating thought. This opportunistic feeding behavior, not uncommon among modern herbivores such as tortoises and iguanas, which occasionally supplement their diets with protein sources. The digestive system of Ankylosaurus likely included a large, complex gut, capable of fermenting plant material. This would have been necessary to extract sufficient nutrients from its fibrous diet. Fossilized coprolites attributed to similar herbivorous species suggest the presence of symbiotic gut bacteria, which would have played a crucial role in breaking down cellulose. This process would have produced energy-rich byproducts, allowing Ankylosaurus to maintain its massive body size. Interestingly, Ankylosaurus's broad midsection may have been a specialized design to house its extensive digestive system. The large gut volume would have provided ample space for fermentation and nutrient absorption, ensuring the animal could survive on a diet of relatively low-calorie plants. This adaptation, combined with its sturdy build and slow metabolism, likely made Ankylosaurus an efficient grazer, well suited to its environment. The sensory capabilities of Ankylosaurus were as finely tuned as its defensive adaptations. Its most remarkable sensory feature was its highly developed sense of smell, which would have been vital for locating food, avoiding predators, and possibly detecting mates. Fossil evidence reveals that the olfactory bulbs in its brain were unusually large for an herbivorous dinosaur, suggesting that its sense of smell was on par with, or even superior to, that of many modern reptiles and mammals. Recent studies of Ankylosaurus skull fossils, using advanced imaging techniques, have revealed intricate nasal passages. These passages likely played a dual role, enhancing its olfactory capabilities and aiding in thermoregulation. The convoluted structure of these nasal cavities, which created a larger surface area, may have allowed Ankylosaurus to cool or warm incoming air, helping it adapt to the varied climates of the late Cretaceous period. Vision and hearing also likely contributed to Ankylosaurus's survival. While its eyes were relatively small compared to its massive body, their placement on the sides of its skull would have provided a wide field of view, allowing it to detect predators approaching from almost any direction. This peripheral vision, combined with its heightened sense of smell, would have made it difficult for ambushed predators like Tyrannosaurus rex to catch it off guard. Though direct evidence for its auditory capabilities is sparse, the structure of its inner ear suggests that Ankylosaurus was capable of detecting low-frequency sounds, which could have been useful for sensing the movements of large predators or communicating with others of its kind. Initially, these teeth were mistaken for those of a pliosaur, a type of marine reptile, leading to considerable confusion among paleontologists. However, they quickly realized that this creature was massive and imposing. The sheer size and unique characteristics of the teeth did not align with known marine reptiles, prompting a deeper investigation. The journey to accurately identify this gigantic predator was significantly advanced by Dr. Joseph Leidy, a leading paleontologist of the 19th century. His meticulous examination and publications played a pivotal role in re-evaluating these remains. Leidy's research corrected the initial misclassification, revealing that the teeth belonged to an entirely different kind of prehistoric creature. The newly proposed classification reflected the immense size and formidable presence of this crocodilian, which was aptly named Deinosuchus hatcheri in honor of John Bell Hatcher, a distinguished paleontologist. The idea that a crocodilian could grow larger than most dinosaurs, it's something that stayed with me. When the first fragmented remains of Deinosuchus surfaced, Initial estimates suggested these giants could reach almost 50 feet in length and weigh over 10 tons. While those early numbers were a bit inflated, the truth isn't far behind. Unlike some prehistoric creatures whose size gets scaled down over time, Dinosuchus has held on to its colossal reputation. There are 3 recognized species: Dinosuchus hatcheri, rugosus, and riograndensis. The hatcheri, discovered in North Carolina, gave us some of our first clues about the genus's structure and how it lived. Then there's the rugosus, mostly found in Montana. This species had a more solid build, maybe because it ate different prey or lived in a different environment. But the riograndensis, found in Texas, grew even bigger than its eastern relatives. From what I understand, paleontologists now think that an average adult Deinosuchus was about 26 to 33 feet long and weighed 2.5 to 5 tons. That's more than twice the size of a male hippo. Some individuals grew even larger. Even with the initial overestimate, the reality of Deinosuchus is still impressive, securing its place as one of the largest crocodilians ever to roam the earth. The riograndensis species really stands out. Studies of the Texas remains suggest the largest individuals could reach 39 feet in length and weigh around 8.5 tons. That would make them not only the largest crocodilians ever, but also heavier than most dinosaurs, except for the tyrant king, Tyrannosaurus rex. I remember reading the work of paleontologist Thomas Lehman, who studied the Texas fossils. He offered such fascinating insights into how these reptiles grew and lived. Lehman discovered growth rings in their osteoderms, similar to tree rings. These rings told us a lot about their age and growth rates. It seems some of the largest riograndensis grew rapidly as juveniles and then slowed down as adults. These findings really highlight how much food availability and climate affected how big Deinosuchus could get. At first glance, Deinosuchus, with its brain case, looks a lot like modern alligators. Its body and snout are similar. But beyond this, Deinosuchus was different, with a unique skull shape unlike any other crocodilian, living or extinct. The skull could reach up to 5.6 feet in length, which is about the size of an adult Spinosaurus skull. And here's something that surprised me. Despite its size, Deinosuchus didn't have the strongest bite. A 2002 study put its bite force at about 18,000 newtons, enough to crush bones, but not as strong as you might expect, especially when you compare it to the saltwater crocodile, which has a bite force of 16,500 newtons. But when you look at the fossils, you see that Deinosuchus's skull was specialized. It had conical, sharp front teeth for grabbing prey, and blunt, strong back teeth for crushing bones. This meant it could eat all sorts of things, from large dinosaurs to turtles with hard shells. The bite force of Deinosuchus has been debated quite a bit. Some early research suggested it was around 18,000 newtons, based on the skull's size and structure. But then another study proposed it could have been over 100,000 newtons, almost twice that of Tyrannosaurus rex. Its size and strength made it a threat to other dinosaurs, including Ankylosaurus and Hydrosaurus. Even large theropods like Apalachiosaurus weren't immune. Certain bite marks on their bones have been attributed to Deinosuchus. It's possible that this apex predator influenced the size and distribution of other theropods in its eastern habitat, especially since no other theropod in the area reached its size. Coprolite analysis, that is, the study of fossilized feces, has revealed direct evidence of Deinosuchus's diet. These fossils contain fragments of dinosaur bones, fish scales, and turtle shells, giving us a snapshot of what it ate. Dr. Karen Chin, a specialist in coprolite studies, emphasizes the importance of these findings. The diverse prey items found in Deinosuchus coprolites highlight its opportunistic feeding behavior. It seems this ancient predator consumed a wide range of animals, from large herbivorous dinosaurs to smaller aquatic creatures. Deinosuchus is thought to have used ambush tactics to capture its prey, using its massive size and crushing bite to inflict fatal injuries. Like modern crocodiles, this giant predator likely employed a death roll maneuver to enhance its hunting efficiency. This technique involves grabbing prey and then rapidly rotating, using the predator's body weight and momentum to incapacitate and dismember it. Reconstructing the hunting methods of Deinosuchus involves analyzing fossil evidence and comparing it with the behavior of modern crocodilians. The robust anatomical features of Deinosuchus, including strong neck muscles and a sturdy body, support this hypothesis, making it a highly effective predator in its ancient ecosystem. Deinosuchus experienced a slow growth rate, evidenced by growth rings on its osteoderms. These rings indicate that it took around 35 years to reach full size. Despite this long maturation period, juvenile Deinosuchus were still formidable predators, sporting considerable size and powerful bites even at a young age. Adding to their fearsome nature, Deinosuchus individuals were equipped with large, thick osteoderms, bony plates, that provided substantial protection against predators and environmental hazards. These osteoderms not only served as armor, but also supported the animal's massive body, increasing its load-bearing capacity and enabling efficient movement on land despite its size. Deinosuchus was a highly successful predator, as evidenced by its extensive range. Remains have been found throughout the United States and northern Mexico. During its prime, the American continent was divided by the Western Interior Seaway, a shallow sea, and Deinosuchus thrived on both sides of this seaway. It inhabited diverse environments, including estuaries, freshwater lakes, rivers, and possibly even deeper marine waters, although some believe that the marine remains could have been displaced post-mortem. The adaptability of Deinosuchus is showcased by its preference for estuaries, coastal bodies of brackish water with river or stream inlets. However, it also thrived in freshwater lakes and rivers, and was potentially present in marine environments. Its strong limbs and tail allowed it to navigate both aquatic and terrestrial settings, tolerating varying salinity levels, which further demonstrates its ecological flexibility. If Deinosuchus indeed ventured into deeper waters, it might have encountered other giant predators like Tylosaurus, one of the largest mosasaurs. This interaction could suggest a complex predator-prey dynamic within its ecosystem, influencing the behavior and distribution of various species. Deinosuchus lived alongside a vast array of dinosaurs and other prehistoric creatures. It coexisted with herbivorous dinosaurs like Anodinosaurus, Gryosaurus, Cosmoceratops, Utahraptor, and many others. Bite marks on the bones of hadrosaurs and other dinosaurs provide clear evidence of its predatory behavior. Deinosuchus's presence likely impacted the distribution and behavior of these animals, asserting itself as an apex predator in its habitat. Despite its dominance, Deinosuchus vanished from the fossil record around 73 million years ago. The reasons for its extinction remain unclear. Though climate changes, sea level fluctuations, and competition with emerging predators are potential factors, its extinction marked the end of an era. But the fossil remains of Deinosuchus continue to provide valuable insights into the life and ecosystems of the late Cretaceous period. Speaking of apex predators, in the world of big cats, the tiger, lion, and jaguar have always fought for supremacy, each vying to be the ultimate predator. But there's one ancient beast that towers above them all, the American lion. This was no ordinary feline. It was the largest to ever walk the earth. Imagine a creature so massive that some individuals weighed as much as an adult brown bear, easily dwarfing today's biggest lions. This isn't just another big cat. It's a legendary predator that dominated its world like no other, leaving modern felines in the dust. The story of this magnificent creature's discovery begins in the humid lands of Mississippi during the early 1800s, when paleontologists first unearthed fragments of its skull. They initially believed they had found remains of an unusually large domestic cat, placing it in the genus Felis. This classification, however, would prove to be just the first chapter in a much longer story of scientific discovery and reclassification. As more specimens emerged from the Earth, scientists quickly realized they were dealing with something far more impressive. The sheer size and distinctive features. The American lion. Even its popular name, American lion, hinted at a simple truth we thought we understood. But modern science has a way of reshaping our understanding of prehistoric life, doesn't it? And the story of this massive predator is no exception. I find it fascinating that what we initially believed to be a subspecies of the modern lion has been reclassified, revealing a creature far more unique and formidable than we ever imagined. Detailed anatomical studies revealed crucial differences: a more robust build, proportionally longer limbs, and, most notably, the absence of a prominent mane in males. These distinctions led to its reclassification as its own species, Panthera atrox, the cruel panther. DNA analysis has since shown that it emerged from an isolated population of cave lions trapped south of the North American ice sheets, roughly 340,000 years ago. This separation occurred during a crucial period, leading to rapid adaptations to North American environments. While modern lions are indeed their closest living relatives, the last common ancestor between these species lived somewhere between 500,000 and 1.9 million years ago. It's a testament to how quickly changes can occur under the right conditions. The sheer size of the American lion truly sets it apart from any feline, living or extinct. On average, these beasts were about 25% larger than today's African lions. Its robust bone structure and powerful muscles would have allowed it to quickly overwhelm large prey, while its long legs provided the burst speed necessary for successful ambush attacks. Fossil evidence provides compelling insights into its hunting capabilities. The discovery of Blue Babe, A remarkably preserved steppe bison in Alaska bears the unmistakable marks of an American lion attack. Deep claw wounds and distinctive bite patterns that match the predator's dentition. Even more telling are the fossils found at sites like Natural Trap Cave in Wyoming, where researchers have uncovered numerous prey species bearing the characteristic damage patterns of American lion predation. What truly set American lions apart from their contemporary rivals wasn't just their size, but their exceptional adaptability and territorial dominance. Recent studies of fossil deposits across North America have revealed fascinating insights into their social structure and hunting territories. Unlike modern African lions that typically control territories of 100 to 200 kilometers, evidence suggests that American lions commanded vastly larger ranges, some extending up to 500 kilometers per pride. This massive territory was a necessity, not a luxury, given their enormous size and corresponding caloric needs. The fossil record tells us an intriguing story of their social dynamics. While modern lions live in prides of up to 15 individuals, American lion social groups appear to have been smaller but more efficient. To think that this now extinct creature could generate a bite nearly 3 times stronger than a modern lion, 6 times more powerful than the saber-toothed cat. It's a level of power that's almost unfathomable. Fossil evidence tells a gruesome story. Near the La Brea tar pits, remains of a grey wolf were found, its femur severed clean through by a single bite. What's chilling is that the wolf survived, evidenced by signs of healing. It paints a vivid picture of the devastating force these lions possessed. But what truly captivates me is the idea of their intelligence. They had a notably large brain case, suggesting significant cognitive abilities. Modern panther species exhibit complex problem-solving skills, and it seems likely that the American lion was also a highly intelligent predator. I see evidence of this intelligence in how they interacted with natural hazards. Despite being common, their remains are surprisingly rare in tar pit fossil deposits. It suggests an awareness, an ability to recognize and avoid these traps, setting them apart from other predators like dire wolves and saber-toothed cats. Their range was vast, stretching from Alaska to central Mexico, adapting to grasslands and semi-forested regions. They shared their territory with mammoths, mastodons, giant ground sloths, and even early humans. Warm-blooded or cold, I think we can all agree that Quetzalcoatlus wasn't winning any beauty contests. It had a long, pointed beak, much like a modern stork, but without the hooked tip, and further excavations revealed that the Quetzalcoatlus Northrop skull was larger than that of Quetzalcoatlus lawsoni, suggesting the former was the bigger of the two species. Quetzalcoatlus could also rotate its head 180 degrees, which would have greatly improved its ability to spot prey and avoid ambushes. This led some scientists to believe it might have lived and hunted primarily on the ground, perhaps too heavy to fly effectively and well suited to a terrestrial life. This flightless theory, which emerged around 2010, never really took off, so to speak. Almost all paleontologists now agree that it was capable of flight, largely due to a more recent discovery: unearthed bones suggesting the Quetzalcoatlus had very light, almost potato chip-like bones, which may have made flying easier than we initially thought. This revelation then led to a new question: How did Quetzalcoatlus take off from the ground? And exactly how did it fly? Many theories have been put forth. Some paleontologists describe the enormous reptile leaping into the air by flapping its wings, or even lurching forward on its wingtips, resembling a vampire bat. Others suggest it may have crouched before launching itself 8 feet into the air, giving it enough room to spread its wings and take off. Its secret weapon. Those strong hind legs that supported the massive push required to jump. One study suggests that Quetzalcoatlus was a remarkable flyer, engaging in brief powered flights before gliding, reaching a top speed of 80 mph, which it could sustain for 7 to 10 days, giving it an extraordinary range. Despite being relatively small in relation to its bulk, Quetzalcoatlus's torso was extremely dense and brimming with massive muscles. It could likely take off with just a single leap and maintain its altitude with only a few flaps. After launch, they could probably fly non-stop for 16,000 kilometers, simply flapping rarely to maintain altitude and guide their course. Its short wings were made of tightly packed muscle fibers, ensuring flexibility and strength, allowing for precise adjustments in the air. The extraordinary flight techniques of Quetzalcoatlus even inspired a Johnson Wax-sponsored mission to construct a model flying machine to test flight simulations. The model, about the size of Quetzalcoatlus lawsoni, used a basic computer as an autopilot and demonstrated the effectiveness of the experiment by soaring and flapping its wings through the air. Quetzalcoatlus and other Azhdachids had hind limb proportions more similar to modern running ungulate mammals than to their smaller cousins, implying they were uniquely suited to a terrestrial lifestyle, even though, like other pterosaurs, they were quadrupedal when on the ground.